Today we're going to cover weather. The study of weather, or the study of the atmosphere, is called meteorology. Weather specifically refers to the conditions of the atmosphere at a particular time and place. This is a short-term change. Now, a long-term change, maybe over 30 years, this would be climate. So weather and climate are different. Weather is dealing with what's happening today or tomorrow. It's changing daily. Climate refers to a long-term weather pattern or an average over a long period of time, maybe like 30 years. Some factors that influence weather are temperature, atmospheric pressure, precipitation, and as you can see with humidity and wind, we're going to focus on this as new material that we haven't covered yet. First thing that we're going to focus on is temperature. Remember, temperature refers to the amount of thermal energy in the air. You do need to know, maybe you learned this in 6th grade or 7th grade math, but you do need to know a conversion between Fahrenheit and Celsius. You do need to be aware of in Fahrenheit, you do need to know the boiling and freezing points in Fahrenheit, as well as the boiling and freezing points in Celsius. Celsius is a little easier as it's based on a 0 to 100 scale. Here are the formulas for Fahrenheit to Celsius and Celsius to Fahrenheit. And as I said before, you probably learned this in 6th or 7th grade math. You will need to know how to convert using the equation. So here's some practice you can do on your own. I also provided answers for you. So please utilize that. The second one is atmospheric pressure. Atmospheric pressure impacts weather based on the force or weight of gases in the air forcing or pushing on the ground. The tool that we learned that measures atmospheric pressure is the barometer. And this is measured in units of force per area or pounds per square inch. You may have heard of pounds per square inch or newtons per square meter. Now this is very important, the pressure systems. The red L. The red L is symbolic to red for warm, hot. So the L identifies low pressure. Low pressure is going to provide warm, cloudy, damp, bad weather. Okay, lots of moisture in the air. So usually where you see storms, you're going to have a low pressure system. It's going to be warm. If you think of Florida, very hot, very warm, lots of storms. The blue H, however, high pressure, H for high pressure. When you have high pressure, it's going to be more clear skies, but the blue identifies cool, cold weather. And it's going to be, because it's going to be clear, it's going to be more maybe sunny, so it would be actually good weather. Make sure you know precipitation and the 4 types. Make sure you're aware of the water cycle. We've covered that multiple times. And then let's talk about humidity. Humidity refers to the amount of water vapor in the air. Relative humidity is the amount of water vapor the air does hold compared to the amount of water it can hold at a certain temperature. You can see this on your little weather app on your phone, usually in a percentage, how much water vapor is in the air. The next one is wind. Wind refers to the movement of air. Now this is very important because we'll be talking about wind speed, wind direction, and we'll also be talking about different fronts as it moves in. Okay, wind direction. Wind direction is the direction in which the wind is coming, while wind speed is how fast or the rate in which air is moving in a particular area. And this, of course, can be caused by the high pressure or low pressure systems. 3 things that can affect wind is pressure. When air pressure changes, this can also affect wind. Okay, the steeper the slope of air, the higher the pressure or lower the pressure. The Coriolis effect, because of the spinning of the earth, this can cause the winds to turn and curve and to be deflected. Remember, in the northern hemisphere, the wind will move, the wind current will move right, while the southern hemisphere, the wind current will move left. Now, here are some new terms that you need to be aware of called prevailing westerlies and easterlies. The prevailing westerlies are actually coming from the west going east. So don't get this confused. If it's a prevailing westerly, it's going east. Why is it called a westerly? Because it's coming from the west. So a prevailing easterly is coming from the east going west. And then the last one here, we can see that friction impacts wind speed and wind direction. Friction will slow down wind. If you have drag, which is fluid friction, this pushes against the wind or against the direction that the wind blows, and this can slow wind down. Friction and drag can also help planes and other things such as lifting up a plane as it goes to take off, but it can also cause turbulence. Okay, we have a couple tools that you need to be aware of for wind speed and wind direction. The first one is the anemometer. The anemometer means wind in Greek, to measure wind speed. Basically, because of these little cups, they spin faster and faster, the faster the wind speed, or the higher the wind speed. Now, a wind vane shows direction in which the wind is going. And then if you ever heard of wind chill or chill factor, this is basically how I perceive it to feel. It feels colder than it actually is because of the wind on my exposed skin of my arm or on my body. So it feels colder than what it is because of how fast the wind is going. In a cyclonic flow, at a low pressure system, the wind is going to move in a counterclockwise fashion. This is in the northern hemisphere. But in an anticlionic flow, it's going to move clockwise around a high pressure system. So make sure you know a high pressure system in the northern hemisphere moves clockwise, while a low pressure system is going to move counterclockwise. A sea breeze is going to move from the ocean to the land, while a land breeze is going to move from the land out to the ocean. Now, here are some air masses that you will need to be aware of, and we'll talk about that in just a little bit. But storms basically are a disturbance with strong winds in the weather with a great amount of precipitation. Now, you can see at the bottom, the picture actually shows different air masses, whether it's on land or in the ocean. The letter C refers to continent. It's over the continent, or it's over land, while the M, the lowercase m, refers to marine. It's over water, over water. The letter P refers to polar, while the letter A refers to Arctic. That's identifying the location, okay, in which it's coming from. And then T is tropical. That is referring to it's coming from or near the equator. Now, there's different storms to be aware of. Some of these you'll have to read through. Some of these are very self-explanatory. Thunderstorms versus winter storms, tornadoes, and then hurricanes. And here we see the air masses from that picture that we saw on the previous page. We see the letter C, or continental, meaning on land, while M for marine is over water. And then the locational temperatures, Arctic, polar, and tropical. That's going to be capital letters, and that's going to be at the end after your locational or regional land versus water. Here we can see the easterlies versus westerlies. Remember, easterlies are coming from the east, they're going west. Westerlies coming from the west going east. And then you have trade winds. Trade winds basically extend from the 30-degree marker of the Earth to the equator. Here's the polar easterlies. Okay, it's going west, coming from the east. You can see the arrow from the polar area, the 90-degree. Here's the westerlies. It's moving east from the west. And here's the trade winds to the equator, from the 30-degree marker to the equator. And then we have fronts. We're going to be talking about what fronts are. Fronts are basically boundaries between air masses, a separation. Now, storms usually develop at a front when warm and cold hit. Now, the jet stream This we learned already that the jet stream primarily is at the stratosphere, and the jet stream usually moves across the United States from the west to the east. Okay, there can be a polar and also a subtropical jet stream. Now we're going to talk about the four fronts. There's the warm front, cold front, stationary front, and occluded front. Here's the cold front, identified by a blue color, blue for cold, and triangles, and this is going to be moving in the direction that the triangles are pointing. This is going to bring, usually pushed by a high pressure system. Remember, the high is blue, usually bringing in good weather. So the cold will overtake the warm. Usually the cold will push underneath because it's more dense, pushing the warm temperatures above it. Here's a warm front. It's moving in the direction that the little half circles are pointing. So think of them as little suns. It's bringing warm weather. Here's the stationary front. We have a cold front moving one direction while a warm front is moving the opposite direction, and they hit. Because they hit, they are now stationary, usually pushing warm air straight up, creating lots of clouds and maybe bad weather. Then we have an occluded front. This is basically where a warm air mass is going to catch up between two cooler air masses. It's going to overtake. So here you can see in the picture, the warm air is lifted up above the two cold air masses. Warm air is less dense, so it's going to be lifted up over it, away from the ground. This is going to create a lot of rain above the warm air mass. So the cold air and the cold air and warm air are pretty much going in that same direction. Okay, here are the symbols again for each of those. And then there are four reasons why air masses may rise, or some examples of air masses rising. Here's convection. Warm air rises, cold air sinks because it's more dense. Here's orographic lifting. Orographic lifting refers to air going over a mountain. As it rises from the left on the ocean, it's going to bring lots of moisture up. So on the left side of the mountain, you're going to have lots of clouds, lots of rain, maybe even, it's going to be greener on that side. It's then going to lose a lot of its moisture as it rises up to the top. And on the right side of the mountain, okay, not a lot of precipitation. Okay, here's frontal wedging. Frontal wedging is showing where cold air is more dense. The warm air then rides above the cold air, creating lots of clouds and rain. So the cold air looks like a wedge. And then you have convergence. That's where two air masses are going to hit, forced up. You have a low pressure system, and then you have basically lots of rain. This may form a lot of storm clouds, maybe your cumulonimbus clouds.